You've been told vanilla comes from a beautiful orchid, but your favorite dessert might actually be powered by a hidden industrial mold. We aren't just talking about beaver glands or synthetic chemicals anymore. Discover how wood-rotting fungus is being engineered to hijack molecular structures and replicate that signature scent. Vanilla is comfort. It's birthday cake and ice cream melting down your wrist. It's the smell of warm sugar drifting out of an oven late at night. It's so familiar that it feels ancient, almost natural by default. But the story behind vanilla is anything but simple. And the deeper you go, the stranger it becomes. Because while vanilla is the most popular flavor on Earth, the version most of us consume has quietly drifted far away from its romantic origin story. The truth is that the vanilla you taste today is less about flowers and far more about factories, microbes, and biological shortcuts that would sound like science fiction if they weren't already in your pantry. The classic image is an orchid growing in a humid tropical forest, delicate white flowers opening for a single day, waiting to be pollinated by hand. That image is real, and it's beautiful. Vanilla truly does come from an orchid, one of the few orchids that produce an edible fruit. But that reality represents a tiny sliver of the global vanilla supply. Less than 1% of the vanilla flavor used worldwide comes from actual vanilla beans. The rest is something else entirely, and understanding why requires looking at just how fragile real vanilla really is. Natural vanilla farming is slow, labor-intensive, and unforgiving. Each flower must be pollinated by hand within a narrow window of hours. The vines take years to mature. After harvesting, the beans go through a long curing process involving sweating, drying, and fermenting. One storm, one disease outbreak, or one political disruption in a growing region can send prices skyrocketing. Over the past decade, vanilla prices have surged and crashed multiple times, sometimes becoming more expensive by weight than silver. For global food companies that rely on consistency, that level of instability is unacceptable. So the world found alternatives. And that's where the myths began. For years, one story dominated internet comment sections and late-night trivia shows. The claim was that vanilla flavor came from beaver glands, specifically a secretion called castoreum. It's a great story because it's gross, memorable, and technically true in the most misleading way possible. Castoreum does smell faintly sweet and vanilla-like, and it was once used in perfumes and flavorings. But here's the part that rarely gets said. By the time most people learned about this fact, it was already obsolete. By 2026, beaver-derived flavoring is essentially non-existent in mainstream food. It's expensive, impractical, difficult to harvest, and heavily regulated. The amount produced globally is tiny, and it's mostly used in niche fragrance applications, not ice cream. The beaver gland story survives because it's shocking, not because it's relevant. If you're worried about rodents being milked for your vanilla latte, you're chasing the wrong villain. The real shift happened quietly, under labels that sounded reassuring. Words like natural flavor, words that imply simplicity and safety without actually explaining anything. Because legally, natural doesn't mean what most people think it means. It doesn't mean the ingredient came from the same source it's imitating. It means it originated from a natural organism somewhere in the chain. And that loophole opened the door to something far stranger than beavers. The key molecule responsible for vanilla's signature aroma is vanillin. In a real vanilla bean, vanillin is produced as part of a complex chemical symphony involving hundreds of other compounds. That's why real vanilla tastes deep and layered, while imitation vanilla often feels flat and sharp. For decades, vanillin was synthesized from petrochemicals or wood pulp by harsh chemical processes. It worked, but it didn't sound very appetizing, especially as consumers became more suspicious of artificial additives. So the industry pivoted again, this time toward biology. Certain fungi naturally produce vanillin or vanillin-like compounds when they break down plant material. These fungi evolved to digest lignin, the tough polymer that gives wood its rigidity. Lignin happens to share structural similarities with vanillin's chemical backbone. To a fungus, a tree isn't furniture or shelter. It's food. And in the process of eating it, these organisms perform molecular transformations that chemists spend decades trying to replicate. That discovery changed everything. Instead of synthesizing vanillin from oil or harvesting it from rare orchids, companies realized they could feed agricultural waste to fungi and let biology do the work. Sawdust, corn husks, rice bran, and sugarcane leftovers became raw material. Inside controlled fermentation tanks, wood-rotting fungi were encouraged to convert these scraps into aromatic compounds that smelled remarkably like vanilla. The result could legally be labeled as natural flavor, even though no vanilla plant was involved at any stage. This wasn't an accident. It was biohacking by design. Scientists didn't just find these fungi and hope for the best. They studied them, modified conditions, and optimized metabolic pathways. Temperature, oxygen levels, nutrients, and time were all tuned to push the organism toward producing more vanillin and fewer unwanted byproducts. In some cases, genes were selectively enhanced or silenced, not to create something unnatural, but to amplify what the fungus already did best. What emerges from these fermentation vats isn't a bean, a flower, or even a recognizable organism. It's a purified molecule. Vanillin, isolated, concentrated, standardized. It smells like vanilla because on a molecular level it is vanilla's most recognizable signal. Your nose doesn't care how it was made. It only knows what shape the molecule is and how it fits into your olfactory receptors. That's the unsettling part. Your senses are being convinced, not informed. Taste and smell evolved to help humans identify food sources and detect danger. But they evolved in a world without industrial bioreactors. When a molecule produced by a fungus in a stainless steel tank is chemically identical to one produced inside an orchid pod, your brain treats them as the same thing. There is no warning label in your nervous system that says this came from a decaying log fed to engineered microbes, and the scale is enormous. The vast majority of vanilla-flavored products on supermarket shelves rely on this process, or something very close to it. Ice cream, baked goods, protein powders, cereals, flavored coffees, meal replacements, and even some pharmaceuticals use fungal-derived vanillin. It's cheaper, more sustainable on paper, and far more reliable than traditional farming. From a corporate perspective, it's a dream solution. But sustainability has layers. Supporters argue that fungal vanillin reduces pressure on tropical ecosystems and protects farmers from volatile markets. Critics point out that it centralizes production, cuts small growers out of the supply chain, and hides complexity behind friendly labels. Both sides are right. What's missing from the conversation is transparency. Most people don't know they're eating something produced by microorganisms, specifically chosen for their ability to digest dead plant matter and excrete aroma compounds. That knowledge alone changes how the flavor feels. Once you know that vanilla is no longer a flavor tied to flowers but to fermentation, you start noticing how it's used. It's everywhere, often to cover flaws. Vanilla masks bitterness. It smooths harsh notes. It makes cheap ingredients taste rounder and more comforting. In a sense, fungal vanilla has become the duct tape of the food industry, holding together products that would otherwise taste thin or unpleasant. There's also a deeper psychological layer at work. Vanilla is associated with innocence, simplicity, and safety. We use the word vanilla to describe things that are plain or non-threatening. That association makes it the perfect Trojan horse for new food technologies. People who would reject lab-grown meat or genetically engineered crops often consume bio-fermented flavors without hesitation. Not because they're ignorant, but because the language never triggers their skepticism. Natural flavor sounds harmless. Fungus doesn't. Yet fungus is everywhere. Yeast gives us bread and alcohol. Mold gives us cheese. Mushrooms themselves are fungi, celebrated and prized. The discomfort comes not from the organism, but from the secrecy. From the feeling that something fundamental has changed without asking permission. Vanilla is no longer a story about place. It's a story about process. In the past, vanilla carried the imprint of soil, climate, and human labor. You could taste differences between regions, harvests, and curing styles. Today's vanilla flavor is engineered for sameness. It tastes identical in every batch, every country, every season. That consistency is impressive, but it comes at the cost of mystery. When flavor becomes a molecule divorced from its origin, food becomes more like software than agriculture. And this is only the beginning. The same techniques used to produce vanillin are being applied to other flavors and fragrances. Strawberry, peach, citrus, and even savory notes are now being synthesized through microbial fermentation. Fungi and bacteria are being trained to manufacture aromas on demand, turning biology into a programmable factory. Vanilla just happened to be the gateway because it was expensive, unstable, and emotionally powerful. So when you pour vanilla extract into a bowl or bite into a vanilla-flavored dessert, you're not just tasting sweetness. You're tasting a shift in how humanity sources pleasure from food. You're tasting the point where agriculture meets biotechnology and quietly hands over the reins. None of this means fungal vanilla is dangerous. Chemically, vanillin is vanillin. Your body processes it the same way regardless of its origin. The real issue isn't safety, it's awareness. Knowing that the comfort flavors of childhood are now products of industrial biohacking forces, a larger question. How much of what we eat is chosen by tradition, and how much is chosen by efficiency? Vanilla feels familiar, but its modern form is anything but old-fashioned. The next time you smell that warm, sweet aroma, it might help to pause for a second. Not to recoil, not to panic, but to recognize what's actually happening. A fungus, optimized and scaled, is whispering to your brain in a language it learned from rotting wood and human ingenuity. It's convincing you that everything is normal, cozy, and unchanged. And that might be the most unsettling flavor of all.